Hello, good evening, everyone. I hope we can start our session. It is going to be 5 minutes past 8 o'clock, and no, 7:30, right? 7:30 Indian time. So, and first of all, welcome everybody for our first certificate course on remote sensing and GIS. And today is the first session, and in which we are going to give a brief introduction about the remote sensing. And today we have our eminent speaker, Purandar Rekhu, and he was one of the foremost project scientists at ISRO or ISRO, and he was working on the geology and remote sensing and hydrogeology and remote sensing for the couple of years, maybe more than 5 year experience. So I'm just handing over the sessions to Rehu. Then you can gain more experience and you can study some introductory part of the remote sensing in this session, and in the future sessions you can or we can dive together into in depth of remote sensing. And tomorrow we have another sessions on the GIS. I hope some of you are already registered and some of you are not, but if you are registered, then you can attend tomorrow's. If you are not, you still have the chance to register for tomorrow's sessions. So over to you, Rekhu, so we can start our sessions without any delay.
Thank you, Jishnu. That was a great introduction. Thanks a lot. Good evening, everyone. I'm Purandar Raghu. It's a pleasure to be with you today here as a tutor for this certificate program. I'll be taking you through the session on introduction to remote sensing. So as far as my background, I'm a remote sensing and GIS professional, having worked as a GIS engineer at Garmin Technologies. It's an MNC where I was involved in marine navigation chart development. It's a completely of marine vertical. So I worked with all kinds of global marine datasets globally. Later, as a project scientist at National Remote Sensing Center, ISRO, which is in Hyderabad. My work has spanned various thematic areas, including urban aquifer sustainability, coastal aquifer management, and even in our Chandrayaan-3 lunar surface mapping. So, using remote sensing and GIS techniques. So, in this session, we will explore what is remote sensing and its background, history, and types of sensors, like under sensing types like active sensing, passive, remote sensing type, and key satellite platforms, which is open source, accessible across the world, understanding the resolutions, temporal, spatial. There are different types of approaches for the resolution as well, and the applications of this remote sensing. So, in agriculture, urban planning, disaster management, like in early warning systems, we get our message from the NDA, like from in our mobile, right? So that's what early warning systems, and free sources of data is satellite data. So that like satellite data. Uh, what are the free sources available in the market to for a student can do his project in his college time or even can practice data. So and they can download, and will after that we'll go through a little bit of basic demo visual data in Google Earth, and we'll discuss career opportunities and Q&A followed by. So remote sensing is a part and parcel of geospatial technologies. So, geospatial technologies in the combination of this remote sensing, global navigation, which we use GPS, famous known as. Other than GPS, there are many other navigation systems as well, GNSS, so on. After that, geographic information system, where we can overlap all GIS and GPS remote sensing data and make a GIS layers, thematic maps which we make. So we'll bring all this together and finally we get geospatial information. So for all this basis is starts with remote sensing. So for today, we'll dive into the remote sensing. So its background on history, like how it exactly started, what's the need to start this remote sensing. So we all know, like there's a saying in English, necessity is the mother of invention, right? So it's all started at the time where industrial revolution has started, like early 80s. In 1839, the first ever photograph was first photographed by Louis Daguerre and Napsy. That is the beginning actually for the photography. And later in mid 80s, like mid 80s to 1900, photographs was taken by these captive balloons and pigeons. So that was the primitive techno way of approaching. Like that is the starting baby steps to the remote sensing in the remote sensing. So obviously people have started with pigeons, like but it we may get some kind of photograph, but it is not in a definite path. The birds can fly in the different direction, whatever it want. So for that, that's the major drawback in that. So for that, we need a economical object which can be used for larger areas. We can cover larger areas. So for that, we people has moved to hot air balloons. So it has it we can navigate this hot air balloon in a separate in a certain direction. So make sure, but it has its limitations. So if strong wind gust is there, it will deviate from its path, right? So depends on these are the just kind of upgradation in a platform, like from starting with pigeons, later they have tried with kites, later hot air balloons, and moved to helicarriers, and moved to we can say airplanes. Now UAVs and technology has upgraded. We are using UAVs and drones, right? So now how it started actually, how it came into the existence, like in during World War I, we mostly not we like humankind mostly relied on aerial photography. So but it has limitations. But aerial photography, we cannot detect the area which is underneath it. Like it can be camouflaged. The trenches during the World War I, trenches and ammunitions, arms, they can be camouflaged, right? So for that, we relied, like we adopted new technology depends on electromagnetic spectrum, like which means we have increased our vision beyond our visual range, right? Electromagnetic spectrum increases the include infrared and microwaves. Now followed by Cold War, the time is changing. So like reconnaissance techniques has developed and launching the spy satellites. Even from at this time we went to aerial photographs to space, right? Spy satellite. The first ever artificial satellite launched into space was Sputnik 1 by the Soviet Union in 1957. Later followed by US for the scientific studies, meteorological, and followed by Landsat, and later India has also joined in this race. So this is the first ever known aerial photograph was obtained by grasped flex, like famously known as Nadar and Nadir. Yeah, later this term has much more importance in remote sensing, because which exactly reflects the point on the surface, which exactly coincides with the platform, which is above sensor, midpoint of the sensor. Like so, here we can see first aerial photograph. This first, so they tied camera to the threaded balloon at 700 feet, right? So we can see this is a certain kind of angle. It is looking at the city, and the roads. We can understand the buildings, right? So later, what happened? After 2 years, it took 2 years to develop again. See, oblique aerial photograph was of downtown of Boston City obtained by some of the scientists. A balloon. Now they have used proper hot air balloon at an altitude of 1200 feet. Even though height was bit low, but angle was different. See, we can see horizon here. There is a sky, clouds, and the city. So this is called high angle oblique photograph. This is basically kind of oblique photograph. It's a different. If horizon is visible, it's high angle oblique photograph. If it is not, low angle oblique photograph. So okay, what's exactly different? So we can in this we can clearly understand in which direction sun is falling, shadow is in which direction it is going away based on the sun, and we can say like main thing, and more spatial view we can get. Like if here it is we have to take n number of pictures to cover entire city, but here so maximum the count of pictures will be less based on, but detail will be more in this picture, but details are less in this picture. Depends on scale and area, spatial resolution. Well, we can discuss all those later. First we'll understand what is remote sensing, and how this electromagnetic energy, which we mentioned earlier, is affecting is or is it at a kind of use we are our remote sensing technology is using this electromagnetic energy. Remote sensing is nothing but is a detecting and measuring electromagnetic energy emanating or reflected from the distant objects made of various materials so that we can identify and categorize these objects depends on our objective of the study like class type substance or spatial distribution depends on whatever the well. So major key words you have to remember is detection and measuring of EMR, electromagnetic energy, which is reflected from the objects, various objects. So these various objects in the sense, the light is reflecting from a freshly concrete surface will be brighter, much brighter than the older concrete surface which is already cracked. Okay, so this variation will be varies because depends on the material and it in angle of incidence. All this comes into the picture. So as we know, this is the basic diagram for the to understand EMR spectrum. We already know like violet to red. This is what our human eye can see. This is what visible range. After beyond this range and we cannot see with our naked eye, but we can sense. For example, if you stand under sunlight, you can see the light and you can sense the heat which is coming from the sun, right? But if you stand under in moonlight, you can only see the light. You cannot feel that warmth in the light, right? So it depends on the intensity. It varies. So from gamma to radio waves. Uh, So depends on the this energy interacts with the different type of objects in a different way. So depends on the reflection and the refraction radiation characteristics. We have to, by understanding these characteristics, we can develop a sensors so that we can get the better data while we are sensing it. So the major two types we have to consider during this process, like type of material. The proportions of energy reflected, absorbed, and transmitted will vary from different Earth features depending on the material type and condition, which we discussed. Like concrete is a type of material, but depends on the condition. The deflection will vary, right? That is what this point is mentioning. And wavelength. The wavelength dependency that it is even within a given feature type or proportion of reflected, absorbed, or transmitted energy will vary at different wavelengths. So if we see, this is actually this image is self-explanatory. The water itself has major wavelength in this region, visible and ultraviolet rays vision. At the same time, Earth also had major reflection in better values. We can see in this graph, Earth has made invisible ray. But when it comes to vegetation, we can see like it started somewhere in the red and it is having major peak in the near infrared, followed by this ground surface at the same in thermal infrared and water surface. So why here we are seeing water at the same time we are seeing water surface here. So the water has better reflection in both the reflection and in both areas. But depends on your objective. We have to define the sensor or and we have to choose the sensor because we're not defined but we're not in a building a satellite. We are using satellite data. Depends on your study. We have to identify a sensor which is useful to you. For example, this higher resolution might be useful for oceanic studies. But this can be used for freshwater studies, like that, similar way. So which I mentioned earlier, the band we have based on the sensors, based on this reflection value, we build sensors. Based on the sensors, we get the satellite imageries. So let's see this band one, band two, band three, band four. It is same area. All these four images of same area. You might have heard this name Kakinada, this Geeta Govindam movie. Vijay Deverakonda is a hero. Like so, this is Kakinada area, a sport area, so where Godavari is Godavari is estuary into the Bay of Bengal. This is the barrier spit. If you are from geology background and you can understand this geomorphology as well. This is from IRS, Indian Remote Sensing Satellite, list 3, list 2 data actually. list two, because that has a series of list sensors system, list one, list two, list three, list four. So what this band's exactly representing you is, it's uh, separate imagery. Each imagery is representing you the energy emanating in that spectrum. Like for example, this is we can say this is band 4 is infrared, band 3 is red, band 2 is green, and band 1 is blue. Still, but you can see only in grayscale, black to white grayscale, but you cannot see. But when you can see this, when you fuse this, when you stack this satellite imageries in a there are many combinations for this stacking. There is one of that is called true color composition. 3, 2, 1. We first stack with 3 and 2, 1 followed by 1. So this is what exactly similar to real time, like a real like visible range region. We can see this green portion is which is what vegetation, and the yellow portion is like your land or fallow land, and the blue is your ocean, which is estuary type kind of thing. Blue and yellow, you can see, and the river, Godavari river is flowing in this direction. You can see barrier bars, barrier pits, bars as well. But when we there is another application, another combination where that is called false color composition. We can which gives better understanding about the vegetation and the real ground scenario. So when we saw the when we stack these same bands, like now 4, 3, 2. If you are familiar with this stacking, in further classes you can learn, I guess. Yeah, you can get the, if you stack, you can get the same area in a different spectral value, spectral reflectance. So you can see earlier we thought this is of all of green, it is reflecting green, so we thought it's a vegetation, but it is actually not. It's actually reflecting blue in this, which means it's a lake. But why it is reflecting in this here in natural way, natural true color composition? Because that area, it is a lagoonal environment, it may be affected with, it may be had a overgrowth is am I audible? Hello, can someone respond?
Yes, yes, sir.
Yeah, yeah, thank you for the confirmation. So it is yeah, because of the algal growth we were not able to detect these water bodies clearly, but in this false color composition we can see it clearly. There are many small patches of water bodies in this across this region, right? So that's the importance of sensors and spectral reflectance, EMR spectrum. Based on the EMR spectrum, we can build sensors based on the sensors built. We can access the data, and we depends on our study. So there are different types of sensing, like active sensing and passive sensing, which is a major broad category. So active sensors is like first understand passive sensing. Passive sensor detects sunlight radiation reflected from the earth and thermal radiation in the visible and infrared spectrum, like which we saw earlier. It is like we can say this is like passive remote sensing. For these bands, consider, let's say it was passive remote sensing, because we are red, green, blue. We are matching it here. So we can sense only in daytime, because we are which is reflected from the earth, which my main source is sun, right, for that. But when it comes to active sensing, the sensors and the satellite itself will release some energy onto the surface of the earth. Whatever the reflected energy it get from the surface in that area, so it will record that. So which means source and sink will be the same satellite. So, but here source is sun, sink is a satellite. So from the satellite, we can get that data to our ground station. For ISRO, we have ground stations across the country, from north to south, east to west. And after, yeah, we have to, yeah, there are many flaws, and so that we and at the same time many what we can say, many advantages with the both passive and active remote sensing and types. We have to keep on using both at the same time. Because now we relied mostly on active sensing because it is weather independent. It can penetrate through clouds, rain, and even in a snow time. And it is sunlight independent. It can be operated in day and night as well. So the other major key satellite platforms for Earth observation, I can say, because our IRS series has IRS 182, ResourceSat, CartoSat, OceanSat. These are the satellites. Depends on the study. It varies because ResourceSat as mostly can be used for studies on land use, land cover, forestry. These all. CartoSat also can be used, but these applications are much higher because resolution is very high. CartoSat DEM is one of the highest resolution in India. Because if we can because of with that you can actually study landslides and land movements like land slumping. These all things we can much useful for that's a cartosat. And oceansat, its name itself is saying oceansat. You can study oceans like a forecast, weather forecast and all. So in ResourceSat, we have a series of satellite list one, list two, sensors actually list one, list two, list three, list four. List three has a 23.5 meter resolution, and list four has a 5.8 meter resolution. With the update of the number one, two, three, four, the resolution is decreased because our objective studies were increased. Like we need high resolution data to get the more accurate information of the our surface. And Cartosat is high resolution, and Cartosat 3 DEM is the it has a peak resolution 0.25 meter resolution, which means you can detect the object of even a 2.5 meter resolution on the earth on ground surface. That is what resolution, the spatial resolution means. It is Sentinel again. It's because it's open source, and again Cartosat is not open source. Sentinel is European Space Agency (ESA) developed by them, and they had SAR data, which is synthetic aperture radar. It is kind of active remote sensing. It comes in active remote sensing type, and it has sensors and resolution 10 meter, 12, 20, 10, 60 meter resolution. Depends on the band. It will vary. But bands they have now in resource that we have four bands maximum, but in Sentinel we have around 12 to 8 bands, I guess. Yeah, 8 to 12 bands. So, and Landsat also same. We have this is from USA, NASA. They have series. They started like Landsat series from 1972 till now. It is keep going. The machine. That mission is going Landsat mission, but they keep on replacing the Landsat satellites. 1, 2, 3, 4 up to 9. The resolution are 30, a multispectral resolution, and 15-meter panchromatic. Panchromatic in the sense you can see only grayscale, which means it can comprise the imagery itself comprises of all spectra, all values in the visible region. Multispectral in the sense blue has separate image and red has separate image, imagery like that, which we saw earlier. Panchromatic means comprising of all. It'll take only single imagery. That is what panchromatic means. It has higher resolution than the multispectral. The uses land cover change, land detection, change detection, and vegetation, agriculture, urban planning, and water bodies. So as we saw that this guy is mentioning 10 meter, 10, 20 meters. So this comes in a resolution. There are many types of resolutions. One is spatial, one is spectral, another is temporal. These are the major actually. There are many other resolutions as well, but these are the major. Let's understand each of three. First of all, spatial resolution. So this is a spatial resolution of list 3 of 23.5 meter resolution. It has. So you can see this is entire imagery, spatial imagery. How can I use highlighter? Yes. Huh. This is a spatial imagery of 23.5 meter. This yellow box, which we are talking about. So when we see this is our study area as of now. So we can see this playground, which is very small. We barely we can identify that it is as a playground, cricket stadium. But when we saw that in list 4 data, which is much clear, so we can identify the supporting small stadium here and connective road connectivity. We can identify that. But when we go to again higher resolution data, which is ICNOS 1 meter resolution, it is from the made by US NASA. ICNOS satellites. It has from that we saw the stadium and vehicles on the roads at the same time the pool here and much more. Sorry, much more clear data. We can identify the number of trees around here. We can run some kind of machine learning models to understand the reflectance from this area, and you can count the trees and parking vehicles. Much more applications with the high resolution data. But we cannot do those all those things here. But we can do this with the high resolution data. That is what the size of the smallest dimension on the Earth's surface cover over the independent measurement can be made by the sensor. So we can the sensor can be with the use of help of sensor we can measure the dimension of the stadium. But here we cannot. So that is what scale means. It can be measured up to 1 meter object. Below 1 meter object we cannot measure it, but it can be measured up to 1 meter object. Here it is 5.5 5.8 meter object. We can measure the scale. That's what scale means in broad way. When it comes to our imaging capability with the spatial resolution, this 1 kilometer we have, least we can measure is 1 kilometer in this area, like imagery, and 60 meter and 188 meter. Why we are not getting better data in this, like high resolution? We are not able to identify features in this, but why we are imaging these with this higher scales, like why we are doing that? Because the application may be different. For land use, land cover, building detection, we can go to maximum higher resolution. But when we studying like geomorphological studies, when we understand river pattern, river dynamics, how where the flood can happen, and glacier, and there are some other monsoon, where from where in which direction monsoon is traveling. For that, we have to use this. This is the most reliable scale for us. So that's why we are using this. This is advanced wide field sensor data, AWIS sensor, which is part of remote IRS, and 72 meter, 56, 32, 36, 23. These are resource side data actually. The application will be much bit narrower than AWIS, and followed by Cartosat. We have 2.5 meter resolution, 1 meter, and 1.6 meter. In Cartosat, if we stack together in the true color composition, we can see how exactly it is looking in Google Imagery, right? So this is again microwave, which means SAR data, synthetic aperture radar. So this is it has broad spectrum again. So, and for that is spatial resolution. Now it's spectral resolution. So now we can understand which ability of a sensor to define fine wavelengths. The sensor, the better you make the understand this reflectance value, the better you make sensors, and the better it will capture your data. The finer and the spectral resolution, the narrower the wavelength range of a particular channel or band. This, for example, it's pan, which I said earlier, from 0.4 to 0.7 EM. It will consider it as a with this wavelength range. It will consider it as a one satellite imagery. But in multispectral, it is not happening. It is actually dividing it is divided with the some spectral value. In that range, it is actually clicking like capturing the imagery in that region of the Earth surface, which means it. For example, you made a sensor which can be capable of clicking image in a separate region. For example, if we click a picture with your mobile, it is clicking picture in visible region, what we can see with our naked eye. But this sensor is capable of click a imagery in a region which we cannot even see, like 0.4 to 0.5. And again, green and red. That is what multispectral. Yeah, so this is Ismail region only. That is microwave region, which I mentioned. So this is actually what is actually doing is it is clicking the picture blue separately and green and red, which means we cannot see that in we cannot see that individually, but when we stack it, we can understand it. Hyperspectral. This hyperspectral, which make this band much finer, 0.4 to 0.43, 0.45 one imagery, 0.46 one imagery, up to 5, like for 0.4 to 0.5, it will take 10 image. It may take 10 imageries. So because why we are increasing this band to multispectral to hyperspectral, because of the data reflectance, as much as the data you have, that better you can get the information of the surface. Because for example, let's see, like we'll just go back to the slide which we saw it earlier. Yeah, here. So, for example, I click this imagery, which is of 0.4 to 0.5. But if I using a hyperspectral, I can get better data from this, because the sand deposits has a kind of layers it is showing here. But if I'm using hyperspectral data, I can get much better information in this region, because but it is covered with water in this multispectral. If I go to hyperspectral, I can get much better data. How sand is moving through seasons, like a high tide time, low tide time. So that penetration capacity will be increased. That is why we are going much higher, like a pan to multispectral, multispectral to hyperspectral. That is what the advantage is of hyperspectral, like uh, quantitative derivation of biological and geophysical parameters of vegetation, soil, water bodies, surface, etc. So there are the standard operating values developed by ISRO. Blue has to be captured in between 0.45 to 0.52, followed by green, red, infrared, and SWIR, like short wave infrared. Why we relied on infrared and short wave infrared? Because vegetation has better reflectance in this region. That is what which we saw in fourth slide, I guess. So this is multispectral. It will click each imagery in this regions, but hyperspectral, it will click continuous images. That is what curve which reflects, and wavelength measure. So, and third one is temporal resolution. So we have to understand in which time the crop pattern is changing, or how fast this urban growth is happening. For example, now people are moving from Bangalore to Mysore, because the cost of living and economic viability. The people are now moving from Bangalore to Mysore, because the groundwater issue was there. Urban flooding is happening in Bangalore. So how fast this Mysore is growing? The urban sprawl is happening. So for that kind of detect land, sorry, change detection, we can rely on temporal resolution. It refers to ability of a satellite or to frequently image a given area, either by vertical or oblique. So how many in a certain time span, how many times the satellite is revolving over the particular area, how many times it is capturing the data. That is what itself, like it is explanation. Imaging at different time periods show the variation in spectral characteristics and of different features over different time. For example, we'll understand by seeing these two imageries. In January 2006, this is actually false color composition, which gives us to understand better reflectance for vegetation. In January 2006, because it's post monsoon time, so we can see red reflectance across this region, right? Because this is actually for a fold, if we are aware of this geology. And this we can see this area has a better red reflection. But when it comes to March, it is like pre-monsoon time, like not pre-monsoon, it's a summer time. Yeah, pre-monsoon is, but it's peak some almost summer started about to go to peak time. So now this part has become green, which means vegetation reflectance is much weaker these days. But here it is red is very dark. Why? Because that area has a water supply, because we can see major water body here, and these area may be groundwater irrigated. So that is the reason we can say the based on this we can say like this which area is groundwater irrigated, crop pattern is changing, and how vegetal growth is happening in this a certain kind of area. The more like the examples like it can with this temporal relation you can manage monitor cyclone, flood, volcano, earthquake, this kind of things. Before earthquake, after earthquake, the obviously cities will be disturbed, right? So the how much disaster happened, how much area got affected. With that, by using satellite data, we can understand that. Okay. Yeah, these are the remote sensing satellites with, for example, ultra advanced wide field sensor has a 1 kilometer resolution, spatial resolution, and 30 minutes. So we can get this data every 30 minutes, like a temporal resolution it was. So it is 360 meter spatial resolution has a 2 days temporal resolution, which means it can revolve, it can take imagery every 2 days. It can take every 30 minutes like that. So depends on the study. For forecasting of the tsunami, not tsunami, like hurricanes or this tufan and all, we need regular update how in which direction it is moving. From morning, it is more, for example, in our area like in Vizag, with the most affected area by cyclones from the West Bengal, Bay of Bengal. So we get regular updates from the NDA and National Disaster Management Team. Now we are going to we may expect like kind of lightning strikes in this area. In 30 minutes, you can expect rain, like kind of. So, because based on this data, regular update from the satellite, we can assess that which situation. So that is what importance of this temporal resolution and as well as spatial resolution. So depends on the studies. We have developed different kind of satellites, OceanSat, RISAT, and again Cartosat. Similarly, from the NASA, we have this is actually open data. They have a Landsat series which we much detail with I guess. Yeah, Landsat multispectral imagery land use. Now it's almost 5, 7, and 8, 9. Now now actively performing satellite platforms on the space. And MODIS, it can be used for terrain and at the same time aqua like water. And Aster, it's the most available data. It is the Aster data we can use for DEM elevation data. We mostly use. I used mostly earlier, but depends on the study we can use. The which means the mission what kind of data is it is giving to it is available. It can produce. It can produce optical data and parametric data. Depends on our study, we have to choose which data is suitable for us. The soil moisture, active, passive, like the soil moisture, and we can understand the applying different even with the different sensor indices like NDVI, NDWI. We can get the soil moisture. Actually, these map they made a soil moisture map and they are like NASA has producing soil moisture maps and Frisian which means it can be useful when we are studying glacier and kind of glacier regions. So these are the mostly open source data which is available across the globe, like different government agencies like from NASA, European Space Agency, JAXA, Japan Space Agency, and yeah, our ISRO, NRSC. So depends on the your objective. If you are studying evapotranspiration from the from the forest area, you can go for these data sets. If you are looking for precipitation, you can go for this. But depends on your study, whatever you. So if you want digital elevation, you can go for this time. The Cartosat is our SRTM is again Aster is yours. Depends on your study. You can choose whatever the data. But this is all open data which is available on the market by the government agencies, not private agencies. Private agencies also you can go, but those are priced. You have to pay the like Maxer Technology, Maxer, Pixar, many other. Now, when we come to ISRO, Bhunidhi is a portal where you can access all the data, like all the satellite data, which is developed by Boon team. So now, latest space policy changes in space policy in 2003. Uh, Data products closer than 5 meter resolution, which is as we are in condition, free and open for all. Like you don't need to pay any kind of money while we are downloading 5 meter or coarser than that, like 5, 6, 7, what we are using for. The open data dissemination as direct and download. There are two ways while you're downloading the open data. Direct download, last 3 months data, I guess you can download it directly. If it is exceeding 3 months time, you have to order it, but it is free. They will send it to you within 2 to 3 days. Depends on the availability of the workforce there. And now they are automating all the process, and now you can get how you're if you're available, if you're familiar with the European Space Agency website, you can get a API key. With that API key, you can run some kind of machine learning models without even giving your ID and password. Every time while for the downloading data, you can access and generate the data whatever you want. So if you open the web portal, like Bhuvanidhi portal, this is how it looks like, the application and the type of products and programs that they had. For example, if you want to go for kind of water resource, deep water resource kind of data looking for, there are urban water body information system, which is focused on urban water, like water bodies, surface water body, and spatial flood early warning systems, satellite derived ET, over observation GLOF, which is again for our glacial region. Like GLOF itself is a glacial lake outburst flood risk assessment. Like we saw Kedarnath flash floods, how it is happening because somewhere in the top of the hill there are some kind of lake, glacial lake. Due to the heavy rainfall and ice melt, that lake will flood down. So it will evaporate. It will clear everything in path. And like based on that, we can access different types of data. You can register and log in. This is the how when you register, but you have to give organization in which organization you are working. If you are a student, you can give and depends on or your study, like your geology from geology background or your environmental background. Water resource department, like this depends on your. You can use to it, like it is just one time. If you see it, you can get it. Yeah, the, understanding while downloading, the understanding this filters is much important. Like what resolution you are looking for. For example, if you're looking for resolution kind of greater than 5, coarser than 5, so you can access all the data freely. But if you're going for much higher resolution, 2, 3, 1.3, like Cartosat and all, you have to pay for that. And satellite after one, like we have to, like we will go through it time permits, like we will give a demo how to download the data. The satellite, we have to select satellite type, which satellite you want, and sensor type. For if I'm selecting resource set, I have to select sensors like list 3, list 4, depends only. If you need high resolution, you can go for list 4, or if not, you can go for list 3, depends on your study. So on order, you can get it direct download. This option is available, you can download it directly. You can see like this, it will come like this. If it is not, if it more than back then 3 months, then you can have to order it. Similarly, same criteria happens in this USGS portal as well while downloading the data. So you can download, to understand the filters, you can load your area shapefile, which area you are focusing on. And yeah, that's how you can finish this. Now it's demo time. Let me close this PPT. Let me minimize this PPT for now. Yeah. Is it still visible? Hello? Hello? Can someone respond? Is it audible, right?
Yes, it's audible.
Yeah, thank you. So let's start with this. So as it mentioned in your program schedule, um, we'll try to make some kind of modeling in this. Modeling, we'll get familiar with the sorry, Arc 9, Google Map, Google Pro, Google Earth Pro, because it's a software like you can download it freely, Google Earth Pro. It is available on the Chrome. You can download it whenever. Yes. So let's understand. So this is our India, right? So now we try to understand what are the features this application is providing. So based on this, in which way we can use it for our study. For example, you can make some kind of KML file. In this, you can make some path or even some kind of shape files. If I'm looking for a city called Mysore, which I mentioned, which one. So I can do this like this, like so. I go for a polygon. So this is polygon, add polygon. So this pop-up will come. You have to create by yes Mysore. So now you can simply trace. You need a outline like AOI, Mysore AOI, area of interest. You can change color of the outline, or even you can make it transparent. The area which you are looking for, the entire area you can make it as filled if you want like this, or if you want outline only outlined, and make it how much it has to be. It is filled at the same time. If I give 10%, sorry, 20%, 30%. Yes. See, we can, it depends on your usability, how you are used to handle this kind of software. So the bit depends on that you can give. You play with the this application. So when you use it. So now I got this AOI. Now I want the elevation profile of this Mysore city, how at what elevation the city was sitting. And there is a hill, Chamundi Hill, famously known for Chamundi Temple. So now what kind of data we can get from this? Like what's the highest elevation of this area, this peak, and lowest elevation in this Mysore city. For that, we have to go for another tool called add path. This. Yeah. Yeah. And so another tool called add path. So again, I say path, mm, my path. So I will trace it like this, in this way. Okay. So now let's try to understand this. Now I've drawn a line. So I'll go right click and show elevation profile. So now we can get the data. So there's a pointer which is red pointer which is visible on the which is moving with my along parallelly with my cursor, right? So when I reach that lake area, this is actually lake. Okay, this is yeah. When that's the lowest elevation of this area in my path, which is 749 meters. So, and it is also showing from that beginning of my path, I have come up almost 6.9 kilometers here. So if I keep going, now the highest elevation of this peak of this hill is like 1052 meters. Got it? Like this is how you can understand the geomorphology, how it is affecting the based on this elevation, what you exactly get. Because based on how water flow is surface water flow can be we can get how in which direction water flow is flowing, what flow is happening. So if we are and if we have to direct urban flooding into lower elevation areas, this is how you can assess the understand the regional elevation profile. So if you go much deeper in this, so yeah, so you can see like here highest elevation again deep came and again it's bit of elevation it is happening. So you can see it is much accurate than the our remote sensing data. The elevation is this much accurate. And if you want to, for example, you collected some one rock sample here in geology, what we do is we collect some rock sample in this portion. We'll divide the city in equal portions. We'll collect rock samples across the city because we want to understand the lithology of the area. Like so, we collect one rock sample here. Okay, so I will put one geo pointer here. So I'll move it here. If I say rock sample one R1. No, sorry, R1, right? So I can change this as well. So for rocks, I am giving some kind of what is available? Soil. No, it's not available. Fine. Let's keep it. So you can depends on your style. You can change if you want to. If you're interested in this kind of changes, you can make it. Otherwise, you just keep it what it how it will. So R1. So I went here again in Bogadi, some area. I found another rock sample change in little life. So I collected another rock sample here. Okay. So, yeah, similar. We can geotag this data, our data, whatever we had, and we can make maps out from it. So we can export map like you can project you can view your maps in Google as well. But we need to do some process. But yeah, it is possible. Otherwise, you can export this as a KML file. This is much mm, go-to process, I would say. So my path, I can say this on desktop. So I can see this on my QGIS software. Oh my God. Let me get it right. Yeah, my path. If I'm placing this my path, yeah, this pop-up will come. Add layer. So it is falling somewhere with the georeference. It is georeferenced actually. So it is falling somewhere in the if you have base map, then it will exactly sit on the base map. Exactly same path which you had. So other than that, yeah, you can do now like if you are going from some place like this if you're going from your mama's house to grandmother's house you can you don't really use, but if you're going to some new temple, we will make a map, like we'll search in a Google map. We open Google Maps and we'll search the destination. It will go show us the shortest path available in that area, right? So similarly it is possible even in this place as well. So click right one R1 R2. So the other lithology points. So I can say direction from here, direction to here. So it has given me a path to travel in a say like in faster time, less time, which can be avoided by other traffic routes and all. The later, the filters you can apply it later, but this is how majorly you can do it. This is the applications like users of this application. You can do what depends on your study. If you understand the application better, the much better output you can give. Yeah. So now I think it's now 8:30, almost over, but still we have time up to 9 so that we can see some kind of data downloading. Shall we, guys?
Yes.
Hello? Okay.
Hello.
Yes, yes, audible. Hmm. So this is again our, let's focus only for our Indian. Right. So this is our Boonidhi portal. So if you log in, you can log in with your own credentials with this. So the how you can download the data. So but that is what which we discussed earlier, right? So exactly what is the main things you have to learn in this to understand and to make your download process more smoother. So now in you can this location, based on location, you can identify your area, or based on polygon. If you have lat long values, you can enter those lat long values, and you can get the that area here like this. Okay, if you give lat long like this, it will create a generate a automatic square on body on this. And if you have a shapefile, it should be in a zip format. They have a that zip should contain .shp, shx, dabf, and pgr file. If you have KML, and you can load KML. Now I downloaded KML, I guess. Go to draw. It has drawn the Mysore OI. So to draw this, there is a separate. Yeah, if you have AOI, then you can do it. But if not, there is a you can take a screenshot of this, or if you're recording already, so you can see this website GeoJoson. With this, you can easily get the download. You just draw whatever the way you want, and you just simply download shapefile or even KML. Just simply download. That is much easier to get better than that. So I'm just giving suggestion. This is how you can draw whatever the way you want, and you can. That's the best shapefile. Best way to fastest, quickest way to get your data done. So now understand these filters. So now go to this open and priced data. So open data in the sense it is available for free. Price is you have to pay, and price data is not available for public. Any government entity can only can get that data, like IRS, remote sensing satellite, meteorological department, whatever the government officials they are using, they can get this data with the price. Open data is open for all. Anyone can access this. And resolution, as I said, the space policy, 5 meter and more than 5 meter resolution is free. The medium, low course. The high and very high is not available since we selected this open data. So I selected this five to run these three, these two, okay. And imaging spectrum. This is optical will mostly go for resource data, depends on my. And I select resource IRS satellites, 1A, 1B, that would be enough. And again, resource at, oh yeah, this, oh my god, 1A, 2, 2A. Yeah, and sensor type. So it depends on the selection. You have selected 5 satellites. In that satellites, what kind of sensors available in there? So in that, those automatically get highlighted in there. So I'm looking for list 3, list 4, all list 1, list 2. I will select all, whatever I need all. So products you can go georeferenced. If you want NDVI tiles, it is ready-made NDVI you can get. or you no need to make any kind of NDVI later. So teams, what you are exactly looking for? If I'm looking for geohazards or urban studies. Depends on you can select that. And sensor optical data. So sensor max. Yeah, this is of the available open data direct. You can download it directly. Resource at which are but earlier I selected this. You can see. Other than resource set, I have selected IRS 1A, 1B, and resource set 1. But those are not available for the direct download. Only resource set is available. This direct download you can download immediately after once you are applying these filters. At the end in the cart or search results you can get it. But for these IRS satellites you have to order. They will deliver in 2 to 3 days within 2 to 3 days. They don't. It's free of cost. So because there is a in storage system, there is a terminology, the standard storaging and backup storage. I wasn't sure, but last 3 months span, which is readily available, you can download it directly. But if your time span is more than last 3 months, then you have to place it on order. So okay, advanced filters. This filter is okay. Sorry. Yeah. Great. This is all of direct download, so no need of any advanced filters, I guess. Yeah. See, now we went directly. So, if you log in there, the advanced filter option will be available. So that in that the one filter you have to add that is a cloud range 0 to 100% it will show. But if you keep it the 0 to 10%, then you can your final output like you will get a it will show a data which is free of this cloud free data you can connect. But if you don't apply that filter, you have to keep searching like that, which is better and what kind of data is how to use. So this is a span, like this is actually the imagery. See, my AI is here, but imagery which is overlapping these AI, it will show you all the imageries. So depends on your study, which imagery is covering your area better, cloud free. So based on that, you can select. You can download the data you want. So as of now, I'm not downloading because I have to log in. So it just simply download. Similarly, with the Earth Explorer search criteria, KML. Similarly, same way what you done in Bhuvanidhi portal. Similarly, you have to done in the same way here. So I can. Yeah, it is uploaded. Yeah, close. I can see this again. My Mysore OI, it is showing here. So these are the noted lat longs it has, and here you have to give the date range from when we want. I said I need from the January of 2005, first of 2005. I've kept this date range actually last 6 months. You can select which month data it has to show. You can select and till today I selected. So cloud cover. I have made a cloud range. Like you can make this kind of adjustment in the cloud coverage. So I kept 0 to 10%. Let's say okay. And if you want to add any additional criteria, you can add data sets. So which data set you are looking for? I'm looking for Landsat. So I'll go for Landsat mission where it is actually. So I'll go for Landsat. Landsat level 2 collection. And I'll select this Landsat 8 and 9 because this is very latest data. Okay. And result. Searching for it. So now I got it's showing the Landsat imageries which is covering my area. So based on the, you can again you can populate this satellite imageries you like this. Yeah. See, yeah. Now this satellite imagery is covering my area. It is. So it's, even though my area is very small, but it is still covering it. So similarly, we can choose different satellite imageries, and you can see, okay, if you want multiple, like you want to some kind of to analysis. So now this is May actually, and you go for March data. So in these 2 months, what change has happened, or you can, but it is not possible with the high this much coarser resolution. But that is what temporal resolution means. With high resolution data, you can detect that change very easily, much better way. Yeah. So you can populate this data as well. It will take some time, but it will. Yeah. This is how your the imagery will look like which you are going to download now. If you download this, this is how it will look like your imagery. That is actually it is showing you in a true color composition, and you can make it a false color composition. N number of you can perform a number of stacking patterns. It depends on your study. You can download directly. Yeah, so now here it is asking us 13 files in level 2 surface reflectance bands and 14 files in surface temperature band. So it means one file has included, extra added. Download all files. If you click all, you can download all at once. Add to bulk files, you can add to cart, it will go. But you can select, you want, not, you don't need all these files, right? Depends on your study. You don't need extra baggage on your computer system. So I need only bands, which is a band 1, band 2, band 3, which means blue, green, red, infrared, sphere band. So these specifications it is available on the uh, Google. You can type Landsat bands and it ranges resolutions. Then you will get it. So if I select download all schedule selected, you can it will download all sound files. It will download all sound files. Like this is that easy. Like in it's with practice you can understand, but you have to be more careful while you are applying date range. Depends on the satellite imagery, because for example, you are using you need a Landsat 4 and 5. Now the satellite 4 and 5 is not available with the time range that I have given. The last 6 months I have given, but the Landsat 4 and 5, it's almost decommissioned almost at decades ago. Landsat Lan 4 and 5 decommissioned time. Yeah, it was decommissioned. Landsat 4 decommissioned in 2001, and Landsat 5 were decommissioned to 2013. So if I'm looking for Landsat 4 and 5 data, which means I need a data of 2 decades back, which at that time my society is not even grown enough to this extent. 2 decades back, which means 20 years back. How I want to see how it looks like at that time. So I have to rely on the data, this 4 and 5. I have to select this 4 and 5, and I have to give data time criteria. Should that, where it is? Yeah, date range. So I have to give it 2020, 1997, January to 1998, 2099, January 30. So if I go to results, so you can get the data. This is almost of, you can see 1999 7, and 31. So it's almost at almost no, it's like a 25 years back dated, 26 years back dated. It was 2025. So you can access though this is the open source data available. So you can see how temporal changes happen in the cities. You can understand how rapidly expanding your city land is land cover and geomorphological features. How even though, for example, you can see Kosi is a Soro of the Bihar Kosi River. How this oscillation is happening in the river pattern at what time, at what rate. It's very far, very quick rate it will happen, right? So, but for kind of that kind of studies we can use it. But and if I giving by mistake, if I give this criteria like in okay. Okay, this I have to change, I guess. Somewhere 15, I give this is somewhere in 1999. So if I give any kind other date range other than the satellite time the satellite time span, it won't give you us better results. If it is still matching that 1999 which I mentioned, so that's why we get the data. If you are giving somewhere in 2015 to 2025, it won't show you any result here. It won't display any maps like images here. So these temporal changes you can identify even with this Google software like Google Pro as well. So let's clear this. Yeah. Now your city is looking like this. Okay. But I want to see 20 years back how it is looking. So now I'm going, this is the time, this is the option. So you can go back in time. It's not a time machine. Sad. Now it's 2025. I go to 2005, right? So this is how it's look like. Almost there is no kind of settlements in this place, Bogadi area, which we saw earlier, layouts and all. Well, we had almost no data, no population, like almost these are agriculture fields or fallow lands earlier it was, right? Mostly city was concentrated in this region only. But later 20, now how it is looking. This entire part as a concrete, the LULC has developed, the people has, municipality has expanded and roads, paths, everything is developed. So you can change, can understand what exactly happening in the time. Hmm, yeah, this is with this I think I can stop my presentation. Yeah, now we can go for. Hello, Jishnu. Hello, can someone respond? Hello.
Hello.
Yeah. Hmm. Great. So this is with this I can end my
Hello.
presentation. Yes, yes, Jishnu.
Hello, Rekhu.
Yes, yes,
Yeah, I think you finished the session, right?
yes, yes.
Yeah. So maybe now we can move to the
Question
question and
answer.
answer section.
Yes.
Yeah. So if any of the participants have questions, they can either give the questions in the chat box,
Ah,
or they can turn on their mic
mhm.
and ask the question. Okay. So now the session is open for the question and answer section. Okay.
Hmm. Yes. I'm expecting some questions. If no one asks, I will only ask you questions, guys. Hello.
Hello, participants. Maybe I think we can call their names as long as there is very few number of participants. Maybe we can
Hmm.
call for their name and Mm, maybe. First of all, any of you have any questions?
Sir, I want to ask there way possibilities to observe data of underwater by remote sensing. Underwater in the sense, are you referring for groundwater? Underwater. Say yes if it is. You're looking. Your objective is you mean groundwater, underwater in the sense. Okay, if it is, if you mean it is for groundwater, I want to ask like how deep it is. What is it? No, like if you're looking for kind of yeah, we'll go to yeah. If you're looking for to understand groundwater and all, so we can access we can go for this kind of data, which is mostly most famous for groundwater observation and all. This is GRACE actually. So GRACE is a satellite system. How it works is the both satellites has a flight path in the same way, same direction, but they look the same area in the different in opposite directions, but actually so they actually work on the gravity principle. We can depends on the change in the gravity, it will we can detect the groundwater movement actually. So but it's a very coarse resolution, it is not that high resolution. We can say it broadly, it is useful for groundwater, which is if you are mentioning about underwater, but yeah, it is one these are the and gray water footprints, elevation, hydroshed data is also much more useful for this. And what is the career opportunities with remote sensing and GIS? In remote sensing and GIS, yeah, there is a name like entity, like remote national remote sensing organization. You can after your studies like masters, you are eligible for your scientist C position in NRSC. If you are from water resource department or geoinformatics, geography, geology, and even forest science, urban studies, and aerial ocean related studies, if you're doing kind of a master's in ocean related studies, all of you are available eligible for the to apply for a scientist C position in ISRO NRSC if you have more than 60% in your masters. And other than ISRO, NRSC, there are many. This is actually one of the government organization. There are Space Application Center, and there are many government organizations working on state level organizations like Andhra Pradesh Space Remote Sensing Center, Kerala Space Application Center. I guess Kerala had some space agency. Every state has space agency. This is and Gujarat had, and across India, every state has space agencies, remote sensing agencies or space agencies, space application centers. So other than this government interest, there are many private players recently from last 15 years. In Hyderabad, there are many startups like Skyroot Aerospace, Agista Aerospace Industries, and Dhruva Space. There are many space startups coming in the race now. So there are wide opportunity for remote sensing and GIS specialists if you're looking for in that way. Yeah, you have bright future. But only depends on how we are able to catch that opportunity. That depends on us, our capabilities. And any other questions?
Yeah, I think Ravi. So not Ravi, actually, Raghu.
Raghu.
I think
Yes.
you're right. There is a booming economy around the rocket science nowadays, and recently, Government of India is planning for one satellite launching center in Gujarat. So, in the future, in the near
Yes.
future, there will be a lot of
Hmm.
job
Hmm.
opportunities
Yes.
around the remote sensing, and both government as well as the private agencies are playing a key role. And some of our lectures, upcoming lectures, are from the Tata Steel and also from other private sectors. So, yeah, you have a lot of opportunities in the upcoming years, especially in this field. That's why we introduce this course to everyone. Okay, so maybe Raghu will give another sessions in the near future, and also everyone can have his contact if you have any doubts. on the lecture, as well as we will provide the recorded sessions to you and the certificates after the two different sessions. Okay, then if there is no more questions today, then we can wind up. And otherwise, we will take more questions. Is that okay, Raghu?
Yeah, that's good.
Yeah, I think Devika is asking for PPT.
Yeah, I can share that with you, Jishnu.
Okay, yeah, we will share.
You can
If
share.
you are willing
Yes.
to share with us, then we will forward to
Hmm.
Devika. No problem.
Hmm.
And if any others are needed, then you can contact us. Okay. Hmm.
Yes. Great.
So
And nice
for today,
meeting you
we
all.
will.
And yeah, continue, Jishnu.
Yeah, no problem. I'm just saying, like, maybe we can wind up for today. And
Yes.
the crew can also give give some suggestions to the participants. Then after that, we can wind up.
Suggestions?
Um, yeah, like you
Okay.
already been in this sector for a long time, so you
Yeah.
know how it's work
So,
rather
to
than
be a
others.
yeah, to be a one suggestion I can mention here, to be a better geomorphology scientist or better cartographer, GS engineer, or we can say GS analyst or geoscience geospatial specialist, whatever the role you are going to grab, you have to have skills to understand imagery. You should be like how you would behave like a detective. To understand your objective of your project and data which we have to uh, understand the satellite image in a much better in that perspective, then you can get this kind of data. Similarly, like which I show you the satellite data which yeah, with this one, right? So here as a geologist, I saw this is barrier speed geomorphology. I can saw, but if you're from background of oceanic studies, you can understand what exactly happening in this estuary, what kind of impacts this estuarian environment will pose on land vegetation. Though depends on the perspective, knowledge you apply on it, the much better data information you can extract from the satellite imagery. That is what you have to be on foot and to understand develop your skills and to understand imagery. You have to be best detective like Sherlock Holmes. That's it. And congratulations, like good luck for your future all.
Okay, thank you, Ravi. Riku, sorry, Riku. Then I think somebody asked me about the future opportunities. We are also supporting you, especially the people who join with us today for the sessions. We can support you for the PhD programs abroad in remote sensing and related topic. Okay, we will try to do our best for you to get enrolled into some universities with full scholarship. Okay, that we can support you. Okay. Und thank you very much, everyone. We will get back.